Always happening. Okay. It is 6:30 on a lovely Thursday afternoon in slightly sunny but still nice weather, Houston, Texas, out the window over here. And welcome to the Greater Houston .NET Users Group meeting, which is in partnership with our friends at the North Houston .NET Users Group. Today's presentation is going to be by Jeremy Clark about, I'll get back to you, task async, AO8, and asynchronous methods in C#. We're going to start with a few announcements. So our little meeting agenda, the first thing we're going to do is we're going to talk about the meeting agenda. Check. Any announcement and information? I've got a short little icebreaker about Windows Terminal and Windows Subsystem for Linux 2. We'll do a prize giveaway. We must be present to win, and we're going to figure out live how we're going to do that. But I think we're going to take the list of whoever's there, and we're going to randomly pick 2 people to win. And then we'll have Jeremy Clark present the main events. So some housekeeping. Your wireless, you're probably on it right now. So I may not have to tell you where it is. The password is hopefully better than password. And the restrooms, you probably know where those are too. So use them if you need them. Just not on the call, please. Other news, you can connect with us on Facebook, LinkedIn, or Meetup. We'll record this one and we'll post it on our YouTube channel and send out the link. And our friends at the North Houston .NET Users Group can also be reached, websites, Twitter, GitHub, Facebook. All right. And so the North Houston Group also has a sponsor, iSphere. And iSphere has consulting. You can see their information. Let me pop it up real quick for them. Come on, buddies. Houston-based, there we go, I'm thinking big. Houston-based IT consulting and IT staffing firm, proven track record in both private and public sectors. iSphere offers something under this window. Extensive knowledge and demonstrated expertise from IT consulting on strategy, collaboration, information management, to IT staffing to get IT done right. Do they have any jobs? Let's find out. Looks like technical writer. Wow, I'm not sure what that is. Project member, SharePoint developer, .NET developer. So it looks like they've got some availability. So if anyone's looking for a job, looks like they've got some openings. And if anyone else has some information about what companies may be sharing, you can add it to you can add a chat to the meetup or on LinkedIn. Would help other people out to see who's hiring. It's a challenging time right now for a lot of companies, and so it'd be good to share any opportunities that we've got out there. All right. I called this a lightning icebreaker. It's a little bit of some topics that I found really interesting that I feel like would be great to share. It's about Windows Terminal and Windows Subsystem Linux, Windows Subsystem for Linux too. So this came up a lot at if you guys were watching Microsoft Build, and if you weren't, Microsoft Build had a lot of great sessions about the future of software development and Office platforms and Microsoft technologies, and a lot of great demos. It's probably a really great example of that a conference can work virtually if you have enough money and production value to make it happen. But it was really great, and there's a lot of great sessions. And so this is a big part of, this is a good part of the developer track was about these topics. Windows Terminal, and I'll pop mine open here. So Windows Terminal is surprisingly a terminal. But the nice thing is that it's basically a command prompt on steroids. And a lot of people may have already been using things like cmdir or there's the other one that's part of it, some of the different console tools that are out there for Windows. Or you're using MSys with Bash, or you're using something else out there. What's nice about this is that it puts it all together. So you can have your Azure Cloud Shell, you can have your WSL Linux distribution, you can have your PowerShell and make it look good. What's really actually the killer feature, resizing. That for Windows is probably something new for the Windows developers, which makes it a little easier to do some of the more command line centric things in Windows to do more development that way. This article, super nice. Scott Hanselman had a post about how to make your prompt look good. And so you can follow the link to the website. I'll post the presentation up on the meetup, and I'll try to post it wherever we can too. So he has some examples of how to make your prompt look nice, because the default PowerShell prompt is pretty nice. Not pretty, it's pretty ugly. It just says PS1, PS, and that's it. You know it's in PowerShell, but that's all you know. So this gives you a little more stuff about where your path is, when that last command line executed, and also some information about your local Git repository. So it gives you some instructions on how to install and how to set up and themes and a lot more goodies. So this is a good one to look at if you want to learn how to make your terminal more functional, easier to use, looks nicer, and kind of helps you figure out what's going on. And PowerShell. So PowerShell, if you haven't been following PowerShell, PowerShell is now cross-platform by default. So it runs on Linux, Mac, and it runs on Windows. And so that means that if you have a script or a automation or some sort of a utility that you're running in PowerShell, now it can run on any operating system, which is great, because a lot of times what you're dealing with is on Windows, we don't know if someone has Bash. No one on anything other than Windows has CMD to run batch script. So otherwise, you're trying to load something like Python or JavaScript, or you're running something else. So having PowerShell now is really great, because Azure DevOps runs everything PowerShell when it runs the executables. And so you can build PowerShell into some of your automation for your software projects. To get PowerShell, you can get it from here and just install the release from Windows Installer. And that's pretty much it. So then you get, if you have Windows Terminal, it'll automatically find PowerShell and give you a prompt for it, and you can use it. It's a little weird to use for if you haven't been used to it, so it's good to go through some intro materials to figure out how it works and how you get around to it, and how some of the commands are similar and how some of the commands are different. What we found is that we're actually using PowerShell for most of our build scripting on our tools. So whenever we do a software project, we'll have a PowerShell script that will do the build or other automation tasks that we want, because we know that if we've got developers running on Mac with Writer, or they're running on Windows with Visual Studio, or they're running in Linux with VS Code, they can run the same scripting and it will work the same on all the systems, which is super great. Which takes you to Windows Subsystem for Linux too. And so fundamentally what this is there's a Linux kernel that runs in Windows that will run Linux applications using a native kernel. And what this really helps you do is there's some, if you've ever tried to do anything with Python or Ruby and sometimes Node.js in Windows, you'll find that there's some things that just don't quite work right because of the assumptions in the Node NPM modules, or the Python requires a GCC compiler to compile some native stuff, or there's other pieces that have to be set up to make it work. So when you use Windows Subsystem for Linux, so there's a version of Windows that was released recently. So it's called Windows, it's version 2004, but it's not from 2004. And so the branding is all confused. So it's Windows 10, but it's labeled the build 20H2, but it's actually called 2004. So it's good to see that Microsoft marketing hasn't really changed much in the past 20 years. And that naming things is still one of the hardest things in computer science. So if you did follow the links here, and you had the Windows installed, so it walks you through installing the bits and pieces. And there's an extra special piece you'll need to install manually, but it'll walk you through it step by step. And then you'll pick a distribution. So I picked Ubuntu because it is the easiest to run, but you can pick anything that you'd like. So if I'm running Ubuntu, what I've got is, let's make some zoomy happen. So if I have Ruby installed, I can run my Ruby, I can run my Python, if I had installed Python. If I do running some, you can use the same package manager to install stuff. You forget your password just the same. And if I want to install any extra packages, I can do it. So if I did want to install Python, then I could do app install Python. Is that going to pick the wrong? That's the wrong one. I want to pick 3. Let's install Python 3. It was already there. So, so the nice thing is that it's running Linux. So I can say, I can look at it, and basically I look at, it is a Linux kernel running on this processor architecture, but it's the Microsoft build. So if I look at my task manager, I'll actually see a process called VMM, which is my giant process, which is actually the Linux kernel running. So this is the Linux kernel running in my Windows system as a process. And there's a shim between it that lets it contact the Windows drivers to do things, but also to have the native system calls be executed by a real Linux kernel. So some of the build demos actually showed that they're going into some of the graphical stuff too, and they're going to have graphical applications that can run in this environment and then bring up a graphical window if you want to run a graphical application. So this to me is pretty cool. I think it's really interesting because the development environments, there's more and more cross-platform desire. As you run things on the cloud, it's all going to be Linux, or it's going to be headless, or it's going to be not going to be Mac. It's going to be Windows Server environment, or it's going to be a Linux environment. Or you've got people that are on a client using a Mac, and you want to be able to use all this stuff together, and you want to be able to use the same tools across all the environments, and this is a great way to do it. So the other thing, Visual Studio Code. So what you can also do with VS Code. So if I have my Windows subsystem for Linux running, I can run VS Code, and so the new version has this little guy in the corner. And when I click this, I can actually have it run a new window. So let's do a new window in WSL. And what it's going to do is it's actually going to launch a process in my Ubuntu, and it's going to connect the two together. And it's going to run it natively here. So there we go. So now I'm actually running VS Code pointing to the Ubuntu file system. So when I look at folders, I'm actually looking at my Linux file system here, not my Windows file system. Although I can still get to it by going to Mount C, and then I can go find my other stuff if I wanted to. So this is really cool because I can do my native editing experience in Windows and mess with everything that's running in Linux. So if I'm doing things with line endings that are weird, then I can work in that way. All right, close that, close that. So why all this? Oh, I updated something, great. So this is really interesting because when you go, modern development is going more and more cloud native. You need to be able to run in a headless Linux flavor environment. When you're doing things like running Lambda functions or Azure functions or other things where you need to run a very slim environment, you have to be able to work effectively, develop, debug it, and having that environment native is super helpful. And if you want to change your operating system to Windows, or if you're on Windows, that's great. You can actually use a great development environment. But if you're on switching between Mac OS and Windows, you can stay in Windows if you wanted to, which is what Microsoft wants, of course. But at least it makes it bearable, it makes it usable. So I'll post these links in the meetup, and otherwise you can reach out to me later with any questions or comments. Another announcement, Tony had one that Houston Tech Fest is opening for speakers, I believe. Let's see, I think you put it in the chat. There's a submission form. There's a Google Doc. So if anyone's interested in submitting for Houston Tech Fest 2020. Tony, did you have any information about when it's going to be or how or where?
It's going to be September 12th at Microsoft in Houston.
Oh, all right. Oh, there it is. I just had to scroll up. Sorry. So September 12th, 2020 at Microsoft in Houston. And then there's another announcement. So the Houston DevOps Days conference was delayed. Looks like they did, it was delayed till August, but they recently refunded everybody and they're shooting for April 2021 now. So that's Houston DevOps Days. This is a really great conference. Yeah, canceled ticket refunds. So they're moving it to 2021. Looks probably back to April where it was originally. Houston Tech Fest, usually Houston Tech Fest is here, but the website doesn't update until much later. But the Eventbrite page will usually show up first. But this is still the information from last year. Let's see if this one's new. Now we're just picking. Yeah, 2019. Yeah, so this is the place to watch Houston Tech Fest. I think that there's a Twitter and there's a, I think he's on Twitter as well, but he'll be making a lot more announcements. All right, let's see now. So I wanted to try to figure out how we're going to do prizes. So I saw that our friends at the North Houston .Agents group had a cool little raffle app on here on the website, which I thought was pretty slick. So what we're going to do, Tony, you can see everybody on the list of participants. Is there a way for you to dump that list into a spreadsheet or something, or a file?
We're
going to do it live.
I don't see a way to dump it. Oop.
Okay.
Hang on, let me check some other.
Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8. What I'll do is, we've got a list of people here. And starting from not me, starting from Tony, we'll do 1 to whatever numbers we'll have to skip this guy though. This Jeremy's second screen. Unless there's a nice way to drop this list somewhere. If not, I'll pick a number from 1 to that one. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 20, 21, 22, 23, 24, 25, 26. So 26, and if 13 is picked, I'll skip Jeremy's second screen. So we'll do 26. 1, 2, 26. So 21. 19, 20, 21. Patrick is one winner. And then the next one is 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Jeremy, you're a winner, baby.
Yeah, go ahead and draw again.
Okay, I'll draw again. Yes, that's nice. 20. So that was 21 was actually Patrick down here. So owner is a winner. And we'll get in touch with you with, so I messaged you both on the chat. Respond back to me with your email address, and I'll send you the codes for JetBrains license. And so with the JetBrains license, you will go to JetBrains website, if I spell JetBrains correctly, and it basically allows you to take what you want to get is there is a license for the whole everything, and you'll get that one. So don't get any of the individual stuff. Get the everything license, which gives you one of everything, and that'll be good for a year. And then you get a upgrade pricing for the next part. So JetBrains is really great because they give out a lot of these goodies to our user groups and make sure that they get used well. So I'll reach out to you both with the codes. And in the meantime, I will be passing the control on to Jeremy Clark, who will be presenting. Let me make sure I go to your slide first. There we go. I'll get back to you. I'll get back to you, Jeremy. Task await and asynchronous methods in C#. Tony, could you pass, of course it's John, can you pass the presenter rights to Jeremy?
You should already have them.
Well, no, you gotta give it.
Change role to present.
All right, I got it.
Ah.
I did it. I didn't think I could, but I did it.
Okay. Looks like.
All right, Jeremy. All right, recording is still happening. That's good. So you're on. Jeremy Clark, welcome.
Thank you very much. Really appreciate you having me here. You know, I tend to travel a lot, and it's not happening at all this year. So being able to get out virtually is awesome. So I'm going to be talking about task and await. And the reason I do this is because it was something that was difficult for me to learn. Took me a while to figure out what the important bits were. As we'll see, it's a little overwhelming once you start looking at it. And so I was kind of scared away from it a couple times. So really what I'm looking at doing tonight is spending most of the time in code, because that's how I think. And we're just going to take an asynchronous method and call it. So kick off an asynchronous method and then also do something once it's done, and then take a look at exception handling. So if something goes wrong in that asynchronous method, because there are some things that are a bit tricky, and we'll figure that out as we go. Now, the reason I talk about both task and await is because await, using async await, will cover probably a good 95% of what you need to do. But await is a wrapper around task. So if you can understand what's going on behind the scenes, it's a lot easier to figure out what's happening if something goes wrong, because we know things always go wrong. And then that way, if we do need to do something a little bit more intense, or kind of step outside the box a little bit, we won't be completely lost. So that's really what the goal is for tonight. And I'm going to start out by putting something into the chat window, if I can find it. I apparently lost my chat window. There it is. Okay. So I have a bunch of links for this talk. So my website is jeremybytes.com, as you can see here on the slide. And I have some resources for this, which includes the code samples on GitHub, along with slides and all kinds of blog articles and a YouTube series and. So there's a lot more information than I have time to share with you today, but I've been compiling it over the years. So I would also like this to be interactive. So I'm not going to wait for questions at the end. If you do have questions, then holler at me, or if you can't unmute, holler at Tony in the chat so he can unmute you, but you should be able to unmute. Let's make this a conversation, because otherwise it's me talking to my computer, and I get really bored doing that. So let's get started. I just want to take a look at what task is to start with. So task is part of something called the task asynchronous pattern. And this was an asynchronous pattern that we got with .NET 4.0, which seems like a really long time ago now. I've been doing .NET since .NET 2.0, which is 2005-ish. And I always felt like I was late to the game, but now here we are 15 years later, and we're still doing this stuff. So the thing about task is, when it first came out, it was added to the language. I looked at it and I'm like, this is really important. And then once I sat down and kind of said, okay, what can we do with this? It was just way too complex. And so that kind of scared me off of it for a little while. And then I went back and tried again and said, this is way too complex. And then with .NET 4.5, we got async await, which again is kind of an easy wrapper around task. But at that point I said, you know what, I'd better sit down and figure out exactly what's going on. So when we're talking about the task asynchronous pattern, this is a task-based model. And when we talk about how it works, generally we have a method that returns a task or a task of T. So in this case, here's our example, get data async. So I'm kicking off an asynchronous method, and that returns me a task. Now, if there's a generic type, like a task of T, that T represents the payload that's coming back. So this can either do an asynchronous operation that returns nothing, or it can do an asynchronous operation that returns something. And then when we talk about what a task is, a task represents a concurrent operation. Now, the tricky thing is we like to think about concurrent operations in terms of threads, because that's for those of us who have been doing programming a long time, doing manual threading is a way to get yourself into a lot of trouble. And but we think about, okay, something happens on the main thread, something happens on a background thread, they have to communicate with each other and things like that. Now, the trick with task is a task may or may not operate on a separate thread. And this is actually something that's really cool because the people who write the compiler are super smart and they're way smarter than I am. My job isn't to build compilers. My job is to write applications for end users. So they know a lot more about the internals than I do. And so the nice thing about this is the people who are writing the compiler can figure out if a separate thread is required or not. And me as a developer, I don't have to worry about it. So that's actually pretty cool. Now, the code that I'm showing you tonight is going to use a separate thread because I want to, really show kind of what's happening kind of on the main thread, what's happening on a background thread, and kind of how we can communicate between our two processes that we have there. Now, the thing that's really cool and really terrifying about task is it's extremely powerful. So tasks can be chained and combined in different ways. So, for example, I could have a task that kicks off, and once it's done, another task will kick off. And once it's done, another task will kick off. So we can chain them together. Or I can say, when this task is done, I would like you to kick off these 5 tasks and run them all at the same time, or as close as you can get to at the same time. When all of those tasks are done, I want you to do something else. So that's really cool from a power perspective. From a complexity perspective, not so much. So that's enough slides for now. Is that okay with everyone? If I pause on the slides? Okay. I'm going to flip over to Visual Studio and we're going to look at some code. So let me just run this little application. I'm using a Windows application. This is a WPF application. And the reason I'm doing this is because it's really easy to see what things are on the UI thread versus things that are not on the UI thread when we're talking about a desktop application. So that's why I show this. Now, you might get the impression of, hey, Jeremy's showing all this stuff in a desktop application. It doesn't really mean anything to me because I'm a web developer. And it's actually exactly the opposite. This is more important in the web world. Because what happens is in the desktop world, you can see my amazing WPF application that has 3 buttons that currently don't do anything. Very exciting. And then there's a list box over here on the right-hand side. And it's really easy to tell that I have the UI thread on the desktop. That's all my buttons, it's my forms, it's my interaction with Windows. And I don't want to lock that up because then my application goes into a not responding state. And my user has to figure out, okay, do I need to open Task Manager and kill this, or do I need to keep waiting? So I try to avoid that when I'm talking about desktop applications. When we're talking about web applications, the web servers that we use, I'll just use IIS as an example, have a limited number of threads that are used for incoming requests. So what that means is if I block one of those incoming request threads while I go out and query a database or call another service on another server or something to that effect, if I block that thread, I am now kind of throttling the number of people that can connect to my web server because there's a limited number of those threads available. It's much better if I can say, okay, this process that needs to go fetch data from somewhere, you go run somewhere else so that this thread is available to take incoming requests. So When we're talking about async, we're not necessarily talking about doing things faster, because a lot of times this turns into slower as we're kind of switching back and forth and going between the threads and whatnot. And when I say slower, I'm talking, little bits. But we do often get better throughput because we can handle more requests, or in the case of the desktop application, we can make our users happy by not locking up their code. Okay, so we're going to be looking at two files in this project. And if you follow the link that I put into the chat, it'll take you to a GitHub project. And what I have here is a solution that has 4 projects in it. This top one, people.service, is a web service. That's where we're going to be getting our data. Then I have usingtask.library, and this is a class library that has the class with the asynchronous method we're going to call. And then there's a, down at the bottom, there's usingtask.ui, which is the WPF application with the form and so forth. And then in the middle, there's a usingtask.shared, and that has like the shape of the data objects and some things that are shared across the projects. We're really just going to be looking at 2 files. The first one is going to be the asynchronous method that we'll be calling. Now, I'm not going to be looking too much at how to write your own asynchronous methods, so I'm not going to spend a whole lot of time here, but we'll be able to use this to kind of figure out how to call and handle exceptions and that sort of thing. And then the other file that we'll be using is the code behind for the main form, which is mainwindow.xaml.cs. And I'm just putting the code behind so that we can focus on task and not worry about UI architectures. And hopefully we'll be able to go from there. So what I have here in this person reader object is a class that makes a web service call. So this actually makes a web API call. And this get async method is the one, let me keep that collapsed for a second. This get async method is the one we're going to be calling. Now you'll notice that this method on line 23 returns a task of list of person. So one thing that you'll want to become comfortable with you're dealing with task and await is the concept of nested generics. So I mentioned before that when we have a task of T, then whatever that T is the payload that's coming back. So when I have a task of list of person, what that means is at some point in the future, I will have a list of person objects. So I'm going to get a generic list back that's populated with person objects. And in this case, I'll just click in and we can take a quick peek at what a person is. It's just the shape of the data we're using. It has 6 properties and an override of the toString method. So that's what our person class is. And we'll be getting that from a service. So let me go ahead and start that service. I am using .NET Core 3.1 for this. And one thing I love about .NET Core services is that they're self-hosting. So I can start them from the command line. I don't have to fire up IIS Express or anything like this. It's awesome. So I have a little tool installed, which is Visual Studio Power Commands. And you might want to look for this yourself because I like this. So Power Commands, it's available in the Visual Studio Marketplace, so you can go out and search for it. So if I right click on the project, in this case, my service project, go to Power Commands, and then there's this open command prompt. And what open command prompt will do is it will open a Visual Studio developer command prompt at the location for that project. So I don't have to go hunting for it. Before, what I was doing is right-clicking and opening File Explorer and then clicking on the PowerShell button and blah, blah, blah. So this I really like. And to start up the service, I'm just going to type .NET Run, and that will compile the service if necessary, and it will run it, and this will be self-hosting on a Kestrel server, and hopefully without too much delay, because, come on, you can do it. There it is. Okay, so this is running on, we can see the port here, it says it's listening on HTTP localhost 9874. So let's just browse to that. Host, Okay, don't know where I'm, okay, there we go. And then slash people is the endpoint for this particular service. And this will give me a collection of person objects in a lovely JSON format. So that's in the same format that we saw when we looked at the person class in Visual Studio. So that's where our data is coming from. And I won't go into the details of how it's being called in this particular person reader class. So on line 12, this is called person reader. This is just using an HTTP client to make a call into the service. But what I really want to point out inside this method is what we have on line 25, which is an await task.delay 3000. So if you haven't seen task.delay before, it's kind of like thread.sleep, but you don't have to feel quite as dirty when you use it. So what I mean by that is uh, you might have had a situation where it's like, okay, I don't know why this isn't working, but if I pause for 2 seconds, then it works again. And so in the past, we've used thread.sleep. So thread.sleep 2000 would pause for 2000 milliseconds or 2 seconds. And what's really bad about that is it basically does a while loop and blocks the current thread. So basically your thread just goes bzzz in a really tight loop for 2 seconds, and then it's done. Task.delay 3000 does something similar where the code beyond this will not run until after that 3 seconds in this case is complete. But if we await this, it will do it without blocking the current thread. So generally, if we're putting in a pause like this, it usually points to a bigger problem in our application or our architecture. I'm putting this in here specifically so that we can see there's a delay between the time we call this asynchronous method and the time it returns, because otherwise, since everything's running on the same machine, we would never see that delay. So this is an artificial delay in this case. So we'll have a 3-second pause before we get data back from our service. Okay. I feel like I'm talking really quickly. But the problem is I get way too excited about this. Okay, so I'm going to flip over to the code behind of the form, and this is where we'll be spending most of our time. And right now, I have on line 18 a button click event handler for the fetch with task button that we have on the UI. And on line 23, there's a fetch with await button. And on line 28, there's also a cancel button, but we won't have time to talk about that today unless you guys want to run long, which if you want me to talk more, that's never a problem for me. So what I want to do is I want to use this person reader class that we just looked at. So we'll say var reader equals new person reader. And then I want to call the reader.getAsync method. But sometimes when I'm calling libraries, I don't necessarily have access to exactly what's going on in those libraries. I know we just looked at the code, so we, we know what it is. But if I don't know what's coming back from this, I'll use var as a cheater. So I'll say var result equals reader.getAsync. And then at this point, I can hover over the var, and this will tell me that this is a task of t result. And then down at the bottom, it says t result is a list of person. So this is actually telling me this is a task of list of person. Great. Okay, that again shouldn't be a surprise since we just looked at the code. I'm going to be more explicit here. So we'll make this a task of list of person, and we'll go ahead and call this person task. Okay, great. I've kicked off that asynchronous process. I have a task, which again is a promise at some point in the future, I will have a list of person. Now what? Well, it's very tempting, especially the first time you look at this, to say, oh, well, let's see what properties this has. Well, hey, this has a result property on it. And the result property is a list of person. That's the thing I'm trying to get to. So it's really tempting to say, okay, well, I'm just going to call person task.results. And that's where everything falls apart. Because if result is not yet populated, it will block this thread until it is populated, which means I've just eliminated any of the concurrent operations, right? Because I'm blocking my current thread again. So I'm actually ruining any concurrency that I was trying to get. Now, it's actually a bit more insidious because this application is a WPF application. And if I try to use task.result here before it's populated, I'm going to end up with a deadlock. Because what will happen is calling task.result, that's going to block the UI thread, which is the one that I'm on right now, until that separate process is done. Now, the problem is that once the separate process is done, it's going to wait for the UI thread to say it's okay for it to send something back. And you end up with a deadlock. Ask me how I know. So we really shouldn't use task.result here. Okay, so if we're not going to use task.result, what is the solution? Well, one of the solutions is to use continue with. And this sets up what's known as a continuation. And that's basically saying, okay, I have this task, it's running asynchronously. When it's done, I would like you to continue by doing something else. And quite honestly, this is where I hit my first stopping point the first time I looked at task, because, well, let's see what kind of parameters this continue with has. Okay, before I look at anything else, one thing I notice is this method has 40 overloads. 40 overloads. And so generally that's where I say, okay, you know what? This isn't important right now. I'm going to have to come back to this later. So, I might come back to this later and say, okay, well, a lot of times when the overloads are listed in Visual Studio, the most commonly used one is listed first. So let's just try to use this number one and see what it is. And so I look at the parameter that we need for this first overload. Okay, and this wants an action of task of list of person. Action of task of list of person. Wow, really? Great. Okay, that's the second time that I stopped. Now, another topic that I'd like to talk about is delegates in .NET. And if you actually follow the links for this talk, you'll find a link. I have another presentation / series of videos called Get Funky, which is about delegates in .NET. And that talks about action and func, which are two built-in delegate types. Now, to decode this, what this means is an action means I need to put a method in here as opposed to like an object. I need to put a method in here that returns void, actions return void, and has one parameter, which is a task of list of person. So really what I need to do is I need to give this continue with method a parameter, which is another method, returns void, takes a task of list of person as a parameter. Okay, I think I'm brave enough to do that. Okay, private void, and we'll call this populate list box, since that's really what I'm trying to do here. And again, this takes a task of list of person as a parameter, which I'll just call task here. And then I can take this populate list box, the name, and copy it into the parameter of the continue with. Okay, red squigglies go away. Everybody's happy. I like that. So once this first task is done, it's going to continue by calling this populate list box method. Okay, great. What are we doing here? Well, I'm going to use task.result. Now, I know I told you not to use task.result, but this is different because this continuation will not run until after the asynchronous process is complete. So I know that result will be populated unless there's an extenuating circumstance like an exception or cancellation. So I don't have to worry about blocking any threads here because I know task.result will be populated. And if I hover over this, I see this is a list of person. Okay, that's the actual type I'm trying to get to. I'm going to create a local variable to hold this just for readability. So we'll call this list of person people equals task.result. And then I'm going to put this in the list box by looping through it. So we'll for each over this. So for each person and people, person list box, which is my UI element, .items.add person. So I'm going to loop through this collection and add each one to my list box. Okay, I'm feeling kind of good about this. Okay, let's run this and just see what happens. hopefully my computer is running up to snuff today. Okay, so I'm going to click on the Fetch Data with Task button, wait 3 seconds, and then oh. Ta-da! Yes, I got an exception. And this is everyone's favorite exception, invalid operation exception, right? The calling thread cannot access this object because a different thread owns it. Anyone who has done desktop programming with multi-threading recognizes this error. Basically, what it's saying is you're trying to access a UI element from not the UI thread. Oh, great. Okay, let me think about what we do here. Okay, I remember how this works. So I need to do a dispatcher.invoke and marshal back to the UI thread. And oh man, do I really have to do that? Because I don't have time for that. The reason I got away from doing threads manually so I don't have to deal with that stuff. And it turns out that there is a way that we can handle this without manually handling the marshaling back to the UI thread. Now, if you'd like to do that manually, it's perfectly possible. I've seen someone do it, but I would not recommend it. Instead, I'd recommend using another overload that we have on this continue with method. I'm feeling like number 8 is kind of lucky. So let's see, number 8. Number 8 is a lucky one, yes. So for the parameters for this, in addition to the action of task that we already have, you can see there's another parameter, which is a task scheduler. Now, the task scheduler is the thing that's responsible for figuring out when to run these tasks, what threads to use for these tasks, and things like that. So really, the idea is the task scheduler is the one who has the job of figuring all this out. And normally, what happens is if we're looking at this first task, okay, so we call get async, and the task scheduler says, okay, this returns a task. I need to kick this off. Is it ready to run? Okay, what thread should I use? You know what? I'm going to grab a thread from the thread pool, and we're going to go from there. And then once this continue with happens, it says, oh, well, I need to call this other method. And I'm just going to use whatever thread is handy for me. And you know what? I'm going to most likely keep using the same one that I just used because I've already got it. And so that's kind of the default behavior is the exact thread that's specified. The exact thread is not specified. Now there is a method that we can use, and this is where we learn to love how Microsoft names things. Because on the task scheduler object, there's a static method called from current synchronization context. And it's a method. And it should be clear to you exactly what that does, right? Yeah, from current synchronization context. Great. Ugh. So many hurdles to jump over. So what the synchronization context is it's the context that we're in when this continuation gets assigned. And in our case, we can think of context as thread, although it's not exactly equivalent. So right now, I'm inside a button click event handler, which is on the UI thread. That's where this person task.continue with method is being declared, right? The continuation's not running yet. Populate list box isn't running. I'm just kind of declaring everything here. So when I say from current synchronization context, what I'm saying is, you know what? I would like you to go back to the same thread you were on when this continue with method is called. So in our case, it'll go back to the UI thread. Is that confusing yet? Wow, this is fun, isn't it? Okay, so with this in place, if we run our application again, and then click on our button, and wait our 3 seconds, data. Okay, I'm very excited about that. Okay, so I have data that's actually coming from my web service. Let's see if it's asynchronous. Now, this is really not that exciting over a screen share because it doesn't often work, but we'll try it. So I'm going to click the button and attempt to move the window. Okay, you can kind of see the window moving. Screen share doesn't really do it justice. If anyone has ever done any kind of desktop development, you would be very impressed by that. Because normally what happens if we run something on the same thread as the UI thread, the entire UI locks up. You can't move it, you can't resize it, you can't click a button. It's a terrible experience for the user. So in this case, I can continue to interact with my UI while that separate task is running. So in this case, we can see it is actually happening on a separate thread. Yay. Okay, let's go back and look at our code. So this code is perfectly functional and it will work, but I'm going to make one more change to that. And that's because if you look for examples online of how task works, you will never see code that looks like this. Instead, you'll see code that uses a lambda expression. Lambda expressions are another thing that I talk about. And if you go to the links for this talk, you'll see another set of videos and links called Learn to Love Lambdas. You're going to get the short version here. So a lambda expression, the way that we use it here is as an anonymous delegate. Okay. Now, I talked about how the action that we're filling in is a delegate type. Okay. So right now, I have what's known as a named delegate. And by that, I mean we have a delegate. And it's actually called populate list box. Now, I'm going to take this named delegate and turn it into an anonymous delegate. And I can do that by copying the parameters and the method body of our method. I'm going to Control C to paste that to my clipboard. And then up here, instead of calling populate list box, I'm going to use the delegate keyword and then paste. And what I've just done is inline that code. And to show that, I will get rid of this separate method. Okay, so I just inline that code with the delegate keyword. And this still builds, still compiles, still runs. I won't put you through all that. But you can see I've got no red squigglies, which again, makes me very happy. Now I have what's known as an anonymous delegate, which is a delegate without a name. That's the official definition that you'll find in the documentation. And it's basically just inline code. So I still have a method. I have this delegate, but it doesn't have a separate name. Now I can take this anonymous delegate and turn it into a lambda expression by getting rid of the delegate keyword. And then in between the parameters and the method body, I can add the equals greater than sign, that lambda operator. And now I have a lambda expression. Now I realize this doesn't look like a lambda expression because it is still way too readable. And that's because lambda expressions come with a lot of syntactic sugar. One of those things is known as parameter type inference. And what that means is if the compiler can figure out the type of the parameter, I don't have to type it in. So I don't have to type in this task of list a person. I can delete that. Now the compiler still knows if I hover over this, that this is a task of list a person. Well, how does it know that? Well, let's go back to the parameters for this method. It's saying, well, this parameter is an action of task of list a person, which means it's a method that has one parameter, which is a task of list a person. It's the only thing you're allowed to put in here. I know that, so you do not have to be explicit. Another thing about lambda expressions is if they only have one parameter, they do not need parentheses around them. Okay, so you don't need the parentheses around the parameter. And then another convention with lambda expressions is often people will use single character parameter names. So instead of task, I might say T. And that looks a lot more like a lambda expression now. Now I'm going to back that last one out. I'm going to keep this named task just so we have a little bit of readability. So the reason I show this is because all of the examples you see online will use lambda expressions. I don't think I've seen a single one that uses a separate named delegate. So even if you're not planning on using lambda expressions yourself, it's good to learn them because that's all the code you're going to see online. Okay, and I'll just run this and prove that this still works the same way with the inlined lambda expression. Hopefully, there we go. So I'll click the button, I'll move things a little bit, and then we'll see that our data comes in. So it's still working. I like that.
Hey, Jeremy.
Yes.
I was going to say it's a lot of the tooling that's in Visual Studio, some of the refactoring will help you switch between those. So if they can make it into I know ReSharper does it. I think Visual Studio does it too, where
Yes,
you
it
can
actually does.
swap between them because sometimes it's in a Lambda form and it's unreadable and you want to extract it or move it. And so there's a lot of cool bits in here.
Yeah, let's see what we've got here. Okay, we've got, no, not that one. In this case, it doesn't want to. But yes, I definitely ReSharper does that. Visual Studio does it, I think, from time to time. So I'm not sure how it makes recommendations. It might be along the same lines as if you've used expression bodied members, for example. Visual Studio will recommend you change something to an expression bodied member if you have a single expression. So something that just has one line of code that returns something, Visual Studio will say, hey, you can turn this into an expression bodied member really easily. And it might do the same thing with lambda expression. Since I have a multi-line lambda here, that might be why it's not doing it. But I know ReSharper definitely has more options than that.
You got a question on the chat. Is Lambda expression similar to arrow function in JavaScript?
Okay, so I have no idea. From what I understand, yes, but I am not a JavaScript person, so I am not the right person to ask about that.
Okay, I can answer. It's
Okay.
similar. Same basic idea, but it does give you a behavior that matches like the C# Lambda syntax more than JavaScript function syntax. So, short answer is yes.
Cool. Thank you.
Thank you.
Okay, now this is the code that we needed to call an asynchronous method and do something with the results once it was done. I would say this is not an entry-level programmer thing, right? I mean, we look at this, we have we have generics, we have nested generics. I love task of list a person, that's always fun. We have lambda expressions, we have delegates, action of task of list a person, and this from current synchronization context. If you don't know what that is, you will never find that on your own. I have no idea how I stumbled across that, quite honestly. It was so long ago. All I know is that I was so happy when I found that. So, not really a beginner level thing, but a really common function, right? What am I doing? I'm calling out to a web service and getting the results back, right? But I want to do it asynchronously. So that's why in .NET 4.5, the language team introduced async and await. And when we talk about async and await, this is a wrapper around task that helps us handle the most common function that we will do. So really, this is just a syntactic wrapper around task. If you look at the IL that's generated, you'll see the same, not exactly the same code, but a very similar type of code to if you handle the task manually. So the tasks are still there, but the compiler hides those from you. So you don't have to worry about them as a developer. And so what happens is when we have an await, the processing of our method will pause until that task is done. Now, the thing about this is it will look like a blocking operation because this will look like synchronous code. This will look like code that's like, okay, run, 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 thread.sleep, right? Block the whole thread for 3 seconds and then keep going. It will look like that, but it's not, which is really kind of the cool thing about it because we can code the way that we're used to coding without, and still get the benefit of the asynchronous nature that tasks can give us. So even though it looks like a blocking operation, it does not block the current thread, which is awesome. And then when we use await, we also need to use async with it in order to scope it. And generally we scope it at the method level. And so we'll put an async modifier on our method. And if we mark a method as async, it's not magically asynchronous. All this is, it's basically a compiler hint. And one reason for that is that await was not a reserved word in C#. So the idea is that there's a possibility that in your previous code, you may have used, lowercase quote await in your code without, as an identifier or something else. And rather than risking breaking that, um, the language team said, okay, we're going to use this async modifier. So that basically sets up a scope that says, hey, anywhere in this method where you see the word await, treat it like this special thing that we have here. So that's really what async means. Okay, let's do the same thing that we just did, but with await. And that's why we've got this cool other little button down here. Okay, so I'll start out by newing up that person reader again. So we'll say var reader equals new person reader. And then I'm going to start with the same var result equals reader.getAsync. Now, when I hover over this, one thing that I'll note is the compiler is telling me that this is awaitable. And I like that because what that means is right now, if I hover over var, we're getting the task back. So that's what we saw when we were looking at this manually. If I add await to this, a couple things will happen. First, it's going to get angry at me because even though I have await, I have not marked this method as with the async modifier. So before anything else happens, it's going to say, hey, you should really add async up here. Now, I do want to give you a warning because if you use the control dot, the little helpful refactoring thing, by default, it's going to want to do two things to this method. First, it's going to add the async modifier. That's the one thing we want it to do. Then it's going to change the result type from void to task. And then the next thing it's going to do is it's going to rename it from fetch with await button underscore click to fetch with await button underscore click async. Now, generally, we do want to have async task as a return type, but the problem here is that I'm in a button click event handler. Event handlers are kind of the one place where async void is still okay. And the reason for that is if I were to change this to task, my event handler is not going to work anymore. So I need to maintain the signature of my event handler. And the same thing with the name of this. I'm not going to change the name of the event handler, and I'm not going to append async to this because it's just not necessary in this case. Now, generally async void, like I said, is bad, and we'll see why as we get a little bit deeper into this. But since we're in an event handler, this is the one place we're allowed to use this. Now, when I look at the var result now, I see that this is a list of T, and T is a person. So I have a list of person. That's cool. Okay, let's call this people instead of result. Okay, now what? Well, have a list of person. Let's for each over this and see what happens. For each person and people, person list box.items.add. Oops, sorry, not safe for work. Person, and this does not feel like enough code, but I'm going to try this again. Let's see what happens. We'll just wait for the exception to come up. Okay, so now I'll click the fetch data with the wait button, wait the 3 seconds, and oh, it worked. Is this actually asynchronous? Well, yes, I can still interact with my form, even though that totally did not come across on the screen share. Do it again, and we could pretend that that's more exciting than it actually is. So this is actually working, and it is asynchronous. Now, one of the nice things about this is that I didn't have to deal with this from current synchronization context like we had to do earlier. And that's because the people who built this into the language said, you know what, it makes more sense to default this the other way and say, rather than using, whatever thread is handy when you continue after this await, it really makes more sense for you to stay on the same thread. And the reason is if I look at this code and I have this clear list box method on line 34, and I have this for each on line 37, I generally expect those to run on the same thread because my method just goes step, 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 step. So with await, that from current synchronization context is built in, so it actually defaults to doing that. And that's beautiful for me in my UI application. Now, if I'm building a library, that really doesn't hurt anything, but I can actually get a little bit of optimization if I say, use whatever thread's handy. Because as a library writer, it's not really my responsibility to decide what threads things are running on. It's the people using my library that care about that. So if I'm inside my library, I might say, you know what, just use whatever thread's handy. And that's where this configure await method comes in. You might have heard the recommendation to say, use configure await false when you call an asynchronous method. And what this does is it says, hey, use whatever thread's handy. You don't have to go back to the same thread you were on. Now, it's a problem for our particular application because if we run this and click on our button, we'll see that we got exactly the same error that we got earlier. Come on, you can do it. There we go. Okay, so we'll click on our button and then we'll wait our 3 seconds. And now we get that invalid operation exception that we saw earlier that had to do with our, we're trying to access a UI element from not the UI thread. So in our case, I really like the way that it defaults, but if you're building library code, you may want to put this configure await false in there because now it doesn't have to worry about grabbing onto that context, holding on to it, and then going back to it later. So you actually do get some performance enhancements here. Now, I will give you a warning, depending on what type of code you're building on the web, you may care about what thread you're on. So I talked to a team and they actually ran into some problems because they were using some state information that was stored in the session. And if you do configure await false, you end up on a thread that doesn't have that session information on it. So they actually ran into a bit of trouble with that. So that's just something to keep in mind. But you'll often hear use configure await false, use configure await false, use configure await false. That's why you probably want to do it, but you will want to definitely look at your particular situation. So in our case, I'm going to keep that not configure await false. Okay. Now we do have a little bit of a problem with our application here. And the problem is we're not blocking the UI thread. Now, I know I said it's good to not block the UI thread, but this application actually has a little bit of a side effect. I'm going to maximize it and we'll kind of see what happens. Because I can click on this button and click on it and click on it again and click on it again. And I end up with 3 sets of data in my list box. Wow, that's terrible. Good job, Jeremy. You're obviously not clearing the text box, the list box appropriately. But at the top of this method on line 34, I do have a clear list box method. And what's happening is we're being bitten by asynchronous operations. So each time I click the button, it goes clear, clear, clear. But then again, my methods will be pausing right here in the middle of line 36. 3 seconds later, I get data, 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 and the list box is populated. Great. Now, I've had long discussions with people on where is the appropriate place to clear the list box in this particular application. And the correct answer is it's just fine where it is. But what I'm going to do is I'm going to disable the button because in this case, I'm getting the same set of data back each time I click the button. And let's assume that I was getting different data back calling a web service each time. Well, if someone clicks the button 3 times in a row, they're probably just going to get the last data set back. That's probably the behavior that we want for an application that looks like this. So rather than letting them click the button repeatedly, I'm going to say, okay, our fetch with await button, we'll set its is enabled property to false at the top of this method and to true at the bottom of this method. So I'm just going to modify the UI so that while this method is running, you can't click the button. So rather than, and trust me, I've gone through all the permutations of clear list box. None of them are good. But now if I click on the button, you can see it's disabled. It's grayed out and it doesn't re-enable until after the data comes back. So sometimes we have to think a little differently when we're dealing with multi-threaded applications. So, but now I have to look at this code and say, okay, well, what happens if I get an exception somewhere in this block of code? Well, I don't want to leave the button disabled because that's no good. You know what I would normally do? I'd write a try finally block. So I'm going to do that. So I have this block of code highlighted. I love keyboard shortcuts in Visual Studio. So here's an awesome one. This is a code snippet. So if you highlight a block of code and use the keyboard shortcut Control K, Control S, that's the shortcut for surround with snippet. And then if I type in try F, that's the code snippet for a try finally block. So it'll take the block of highlighted code, wrap it in a try block, give me a finally block, put my cursor in the finally block so I can start typing lazy developer for the win. Okay, I love this kind of stuff. And then I can just take this, re-enabling the button, put it in the finally block. So regardless of if something goes wrong, that'll still re-enable. Now the fetch with task button has the same problem. We click it multiple times, it will give us multiple result sets back. So we'll do the same thing here. So at the top, we'll say fetch with task button dot is enabled equals false. And then down at the bottom, we'll set it to true. And we'll run this code. I think my computer's getting slower as we go. That's pretty impressive. Come on, you can do it. Okay, and then I click the button and it doesn't disable. Great. Okay, well now I've got multiple result sets again. Good job, Jeremy. Let's just set a breakpoint, and I should have left that running and set the breakpoint. But let's do this again. It shouldn't have to rebuild. Okay, so when we click the button and just step through this code, we'll see we disable the button, we clear the list box, then we call the asynchronous method, then we configure the continuation. This whole block is highlighted because we're doing the assignment. Then we immediately re-enable the button and exit out. Again, kind of the joys of multi-threaded code. So basically what's happening is we're disabling the button and immediately re-enabling it. So we actually want to re-enable the button inside the continuation. So inside the continuation, once our asynchronous process is complete, that's where we want to do this. So, and then we will want to deal with exceptions here as well, but I'm not going to do that because I'm about to look at exceptions in a little more detail. But I will pause to see if there's any specific questions on what we've seen so far. Are we having fun yet? Okay, I'm going to take this as we're doing good.
I've got a quick question, yeah. Jeremy. So, I mean, as someone that's worked a lot with the task library, and you've got functions that have like 40 different signatures, and there's a lot of different ways to do things. What's a good reference for people to get like the happy path in working with task?
So there's a couple of resources. Let me do this. Hey, look at this. Oh, yeah, cool. It went the wrong way. I'm going to go to that link that I pasted into the chat window.
Shameful plug.
And point you not to my stuff, because I have not written about those details. So there's actually a couple things that I would recommend. First, you'll see this set of async experts that I have. Stephen Cleary is he is all things asynchronous. So he has an excellent blog, excellent articles on how all of this stuff works. He has really good articles on sync over async and async over sync and things like that. Um, so I would highly recommend him. Lucian Wischik, he used to work for Microsoft. He's the one that actually built this stuff, and he's just the nicest person you could ever meet. And I'm still convinced he's the only one on the planet that fully understands this. But this will take you to his Microsoft blog when he was at Microsoft, and he has a lot of good articles as well. And then Stephen Taub, another great resource. So I would point to these people because I am definitely not the deep dive expert. I'm kind of the what are the basics that we need to get started with this, and then kind of expand on that as you need it. So does that help?
Yeah, for sure. I know that in my learning too, it was tough to find good materials or try to answer questions because the documentation is extremely detailed and completely worthless, and
Yes, I
explanation is
don't
just
disagree with that. Oh, I will point you to another resource. I will add this link because I don't find it on this list, but I have another talk which is more about parallel development. Um, and this actually has a link to a book review, which is Parallel Programming with Microsoft.NET. So this is a book that's actually available for free. It was originally done by the Patterns and Practices team many years ago, but you can see here there is a read for free online. Actually, I'm going to click on this because I want to show you what it does. It'll first of all tell you that there's a newer version of this article. Don't believe that. Um, if you click on this, you're going to get a hodgepodge of articles. But this article, which is still perfectly fine, um, let's see if I can find, I think it's this one. In the introduction, there is this really cool chart. Ah, here we go, which is called Selecting the Right Pattern. And so this is more talking about parallel programming because Task is part of the Task Parallel library. And generally, when you dive deeper into it, you are talking about running multiple tasks concurrently, not just one thing on another thread like we're doing tonight. So what I like about this is it goes through this problem of, hey, do you have a sequential loop where there's no communication among the steps of each iteration? Use the parallel loop pattern. Hey, do you have this? Hey, are you doing aggregations? Hey, is the order important? So it actually has these different patterns for parallel programming and different approaches you can take depending on what your particular use case is. And this was written when it was written before await, but after task. So all the stuff that has to do about task and the task parallel library, completely relevant. When you're talking about a wait again really isn't for parallel. It's really for this one concurrent operation at a time, like we're showing in this current example. So, okay, shameless plug to my stuff. And I'll get the link to that book into the resources for this talk because that is actually important because yeah, 40 overloads. And you have to remember that this continue with, this is just one method that's on task. There's so many of them, right? So there's a lot of them. Now, when you look at continue with, it's actually not as scary as it looks at first because there's some common parameters, like there's a delegate that comes back. So you have an action or a func. And then you have the, or action, I should say, for I think pretty much all of them. And then you have a task scheduler as an option, like we saw. You can also pass in a task or a cancellation token as an option. And another common one is a set of task options if you want to take a little more control. And so a lot of these are permutations of those parameters. So if you actually look through them, there's probably about 5 or 6 actual separate parameter types. And then the rest is just permutations, depending on how many of those you need. So, and actually in the YouTube series that I have on this talk, I do a different approach. I show a different approach to doing continuations and that use some more of those options. So that's kind of fun too. And those are in the articles as well. Wow. I've been doing this for a while apparently, because I keep writing articles and doing more samples. Okay, let's move on to how to deal with exceptions. Because what happens if something goes wrong in my asynchronous process? And to demonstrate this, after the task.delay, we'll leave that 3-second delay in there. I'm going to throw a new not implemented exception. And we'll say Jeremy did not implement this. So now our asynchronous method is going to throw an exception each time we do this. Let's see how our code behaves. And I'm going to start by looking at the at task. Okay. So I'll click the button, we'll wait the 3 seconds, and then we'll see that we end up with an exception here where we're accessing the task.result. And one thing that's interesting about this is an aggregate exception. It's actually not the not implemented exception I threw, it's something that's wrapped. We'll get back to that in just a moment. But I'll start by talking about this task.result. So generally when we're talking about things that are happening on different threads, if an exception happens, it will stay on its own thread unless you go looking for it. What I mean by that is let's change this code a little bit. Okay, so let's stop debugging. And I'm going to comment out this block of code that's dealing with result. So now our continuation is only re-enabling the button. It's still calling the getAsync method on line 23, and it will still get that exception. But the difference is we won't see it when we run our application. So if we run this again and click the button, yes, it's definitely getting slower as we go. So I click on the button, wait the 3 seconds, and then what will happen is the button re-enables. So I don't see any exception here. Unless I go looking for it, an exception will stay on its own thread. Now, what's happening when we access thread or task.result is I'm accessing a result property on a task that's in what's known as the faulted state. So if you get an exception on a task, it is flagged as faulted and results is invalid. Now, I like this approach because it's not saying that result is null or result is empty. It's saying, you know what? You can't even access the result property. That's how broken things are right now. And it will show you the exception. Now, I showed you that it showed an aggregate exception as opposed to just the not implemented exception. And the reason for that is because of the power of task. So like I mentioned, you can have a task that kicks off 5 child tasks that all run at the same time. What happens if 3 of those child tasks are successful and 2 of them fail? Which exception are you going to show? Do you show the one that happens first? Well, when you're talking about concurrency and parallel processing, first is a dangerous concept because things will happen at different speeds on different machines based on how many cores you have and so forth. So what again, the language designer said is we're going to show you all of the exceptions and we're going to wrap them up into an aggregate exception, which is a tree structure. So that gives us the option to drill down into it. So let's first figure out how to um, deal with the exception inside our continuation. So I'll start by looking at some is properties on task. So task has these is properties, which includes is canceled, is completed successfully, and is faulted. So I can say task.is faulted and know that I got an exception. And I can say, okay, well, let's do a message box.show. Please don't ever, ever, ever do this to your users. Never show a raw exception to your users. This is strictly for demo purposes only. Please never, ever, ever do this. So, but I'm going to do it anyway. So I'm going to come here and we'll show the exception. And you might say, well, how do we get to the exception? Well, in addition to a result property, a task has an exception property. So I can say task.exception. Let's say get type, and we'll show the exception type. Now, one thing to notice here is I'm getting this green squiggly with the task.exception. And that's because I'm using C#8 and I have nullable reference types turned on. And nullable reference types is a way to say that our reference types cannot be null unless we explicitly say so. And it's there so that we can get rid of all of our null exceptions. So what this is saying is it's saying, hey, you know what? There's a possibility that this task.exception property is null. So what are you going to do about this? Now, the thing is, I know that since I'm inside this is faulted block, it will not be null because by definition, if a task is in the faulted state, the exception will be populated. So I can use a bang operator here, which is basically saying, I know what I'm doing. Did I do that in the wrong spot? I did. It needs to be here. Is that right? Bang. Yes. Okay. So exception can be null. And I'm saying, you know what? It's not null, and I know it. So the I've heard this referred to as the I don't like to use that language. Um, as an operator that says, I know what I'm doing, expletive. So it's often called the expletive operator because you're saying, I know what I'm doing. Okay, don't give me that. So basically, I'm taking control and saying, okay, compiler, exception is not null here. I know that because task is in its faulted state. Generally, this null checking is smart enough to know that if I said, actually, let's just change this. And let's just say task.exception is not null. Oop. Is that going to work? Does that work? Doesn't. Not equal to null. There. Okay, so if I do an explicit null check, then the compiler's saying, oh, you're checking for that, so it's okay. But when I'm checking the is faulted property, I'm not actually checking the exception property. So I kind of have to say, yes, I know what I'm doing. Um, that's an aside. I put this in here so that you can learn more about nullable reference types. Okay, so boy, that was a long way around that. Okay, now I could say else here, right? So if it's faulted, do this, else do the happy path. I don't necessarily want to do that because I might say, well, you know what? If it's canceled, then I actually want to do something else, handle cancellation. If task dot is completed, then we'll go ahead and do this happy path here. And then outside all of my if statements, I'm re-enabling the button. So basically I'm saying, if you're faulted, canceled, or completed, go ahead and re-enable the button. Otherwise, do what you're supposed to do. So let's run this and see what happens here. Faster, come on, you can do it. I'm pretty sure I'm not supposed to restart my computer in the middle of a presentation.
You can. It might be faster.
I don't think so. I don't know why it's slowing down. Okay, so let's click on the button and we'll get our pop-up that says system.aggregate exception. Okay, we'll take care of the aggregate exception in just a minute. But notice I just hit task.result and I got the same error that I had before. Great. Why am I in this block of code? Well, it's because is completed doesn't actually mean what you want it to mean. Is completed means no longer running. It does not mean finished successfully. Now, the reason I point that out is you notice that there is an is completed successfully property that I have available to me, but that's because I'm using .NET Core. If you're using .NET Framework, is completed successfully is not a property. Your choices are is faulted, is canceled, and is completed. So it's really easy to think is completed means it's done successfully. Nope, it means no longer running. So now, if you are one of those people who are still using .NET Framework, which is a lot of people, you do have another option because task also has a status property. And this has an enum called task status. And one of the statuses is ran to completion. So that means completed successfully. And then if you want everything to be the same, there is also a task status dot canceled and a task status dot faulted. So you can make those conditionals all the same or stick it into a switch statement, which is also kind of cool. So if you're using .NET Framework, you can check the task status for the successful state. Otherwise, if you're on .NET Core, is completed successfully is your best friend. I don't know why they didn't backport this to .NET Framework. I was very upset to learn that this has been in .NET Core since version 1.0. I found it when I was doing .NET Core 2.2, and I'm like, where did this come from? This is terrible. Why did this? No, it's awesome, but why did it just magically show up? And
You'll
why
have to wait
isn't it
for
backported?
you'll just have to wait for November with .NET 5.
Yeah, well, that doesn't make .NET Framework go away.
What is .NET Framework? It becomes the
No,
great inter-
.NET Framework is done. .NET Framework is done. It's not moving forward. Okay, so now I have my pop-up. If I say okay, the button re-enables. I don't hit that happy path. Okay, that was a lot of work to get there. But let's deal with this exception, because again, this is an aggregate exception. Now, unfortunately, the first time I ran into an aggregate exception, I started building a tree parser to get to the actual exceptions that are hiding in here. Because you could say, oh, well, task.exception, it has an inner exceptions property. Just use that. Well, no, this might also be aggregate exceptions because tasks nested in tasks, nested in tasks. So it's aggregate exceptions all the way down, potentially. So you don't start getting tempted in building that tree parser. I'm going to show you a magical method. This is just on aggregate exception. It's not on the normal exceptions. And that magical method is flatten, dot flatten. And what that'll do is that'll take that tree structure and go and collapse it to a single level of exceptions. Okay, now I'm really going to do something that you should not do to your users, but this is strictly for demo purposes only, because I'm going to for each over this. So I'm going to say for each exception in this flatten inner exceptions. Okay. Instead of saying exception.getType, or I'll say ex.getType. And let's go ahead and put the message in there too. ex.message. Message, I did that wrong. Get type. Okay, outside of that, backslash ex.message. That's better. Okay, now, and then you'll notice I will need the exclamation point up here now. So please never do this to your user, because if there did happen to be more than one exception in this aggregate, they would get a separate pop-up box for every single one. So the reason I'm showing you this is so that you can take these nice exceptions and put them into your log or a message that developers look at. We pretty much never want to show raw exceptions to our users. Oh, wow. This is, I'm not sure. Oh, wait, there it is. Okay, it was just hiding. Okay, so now I click on it. And what I'll see is the actual not implemented exception I wrote with my message. So you do have the full stack trace. It's an exception. So again, you can stick that in your log and so forth. Okay, that seems like a lot of effort when we're dealing with task. Let's do the same thing with await. Okay, so I don't have a task here. So I can't really check the is faulted property or anything like that. Huh, what do we do? Well, we actually program the way we're used to programming, which is I'm already in a try block, so I can add a catch block. So I can catch an exception. And in fact, I'll just use the same message that we have up here. A little bit of copy pasta down to that block of code. So the great thing about using await is that if this is what we're doing, which is let's make an asynchronous call and do something once it's done, deal with any exceptions, we can program the way we're used to programming, which is try finally blocks, try catch blocks. I don't have to worry about marshaling things back and forth to the UI thread. It's great. So again, we'll click on the button, wait the 3 seconds. We'll see we get our pop-up box. And we click OK, and the button re-enables because we have our finally block. So that is pretty cool. So what I recommend is that if you're doing, if you can use a wait, definitely do it because it is the easy, least painful way of coding because our code looks pretty much like any other method that we would use. Now, once we need to step outside of that box, it's good to know that task is there so that we can use it a bit more, use the power that's really behind task. So for example, in our case, I'm just calling one asynchronous method. But what if I needed to call 2 or 3 services, right? Okay, so what if I had to call 3 separate services and then aggregate the data? Well, what would happen using await is that this first get async method would run. And then once it's done, the second call will run. And once it's done, the third call will run. So these will actually run in serial. They'll still be asynchronous. They won't be blocking the UI thread, but they will be running one at a time on not the UI thread. So if we actually want these 3 to all run at the same time, then we need to start looking at parallel programming. And that's where we would be using task more directly. So, and I've got an entire talk about parallel programming. So that's a lot of fun if you want to dive into it. But that's basically it. So the cool thing about await is rather than having to understand, kind of again, here's our nested generic types, here's our delegate types, here's our is faulted properties, here's our synchronization context. And excuse me for one moment, I have a beagle. A beagle who just got home, apparently. Okay. So rather than dealing with all of these, kind of fiddly bits that we have when we use task, we can program the way we're used to programming, which is, hey, look, I just kind of write a method. I use try catch finally blocks. It's really, really cool. Okay, so I have a question for you all because this is what I was planning on covering tonight based on the time that's available. If you give me like another 10 minutes, I can show you cancellation. Are there any votes for that? Because I'm perfectly fine to go either way.
Yeah, I'm good.
Okay,
Let's do it.
cool. I will take that. So because our UI does have a cancellation button on it so that we can stop this partway through. Wow. I don't know how the computer can keep getting slower. It was probably a mistake to rerun the application to show the cancel button. Okay, but you trust me, there's a cancellation button, right? Okay, there it is. Cancel. Now, in real life, this doesn't happen. So normally my computer does not slow down as I'm working with tasks. So don't think that there's some inherent, the way I'm programming is consuming memory and I'm causing all kinds of problems. So I'm assuming this is a combination of screencast and WebEx and other things that my computer's all trying to do at the same time right now. So
And Edge and Chrome.
and Edge and Chrome, everything. Yeah, yeah. Chrome is like, give me all the memory. Okay. So first thing I'm going to do is get rid of this, the not implemented exception. Then the next thing I'm going to do is I'm going to add a cancellation token as a parameter to this get async method. because this is how we deal with cancellation. Okay, so we'll say cancellation token. I'm going to call it cancel token, and I'm going to new up the default cancellation token. Now, the reason I'm doing this is if I don't want to break my current methods. So my current methods are not supplying a cancellation token because you know what? Maybe they don't care about cancellation. And so what I'm doing in this case is I'm giving the option of cancellation. So if you provide a token, great. If you don't, there's a default new cancellation token that will be created for you. And when you new up a cancellation token like this, it's in the not cancellation requested state. So it's basically a token that will never be set to canceled. Okay, now I'm going to check the token after the task.delay so that we have time to click that cancel button before this goes too quickly. So I could look at the task and say, well, let me check the is faulted or let me check the cancellation token because the cancellation token has a is cancellation requested property on it. So I could check this and say, well, if it's true, then let's go ahead and set it into the canceled state. Let's make sure that the status is set to canceled. The is canceled property is true, is faulted is false, completed is true. But I don't understand task enough to do that myself. So I'm not going to do that myself. I'm going to call a method that is going to probably rub you the wrong way because the method is called throw if cancellation requested. Now, the reason why this rubs people the wrong way is because it has the word throw in it. And that implies that this is going to throw an exception. And we are taught, as hopefully we're taught, as we're getting into the development world, you shouldn't use exceptions for flow control. Don't use exceptions for flow control. Don't use exceptions for flow control. And the reason for that is exceptions are expensive computationally. Every time we throw an exception, we have to unroll the call stack. We have to put together the exception object. We have to figure out where we are. And so it's actually a fairly expensive operation. So if we're doing flow control, like an if-else statement or do this, don't do that, we want to stay away from exceptions for that and use exceptions for truly, something we don't expect happened. This is truly exceptional. In this case, I will say, let it go. Let it go. We'll see why this makes sense in just a bit. Please don't sing. I'm glad you're muted, but I can see you singing on the video. So in this case, throw of cancellation requested is okay because now the task infrastructure is going to handle this. It's going to set everything into the proper state. Okay, so throw of cancellation requested. Let's head back to our code. And before I hook up the button, I'm going to hard code some cancellation tokens. And I'm going to start with the task button. So when I call this get async, you can see that, again, there's a default optional parameter here that I have for a cancellation token. I'm going to new up a cancellation token and pass in true to the constructor. And what this will do is it will create a cancellation token that's in the cancellation requested state. Now I'm talking about cancellation requested or not cancellation requested. One thing to understand when we're talking about cancellation, this is not a halt, this is not an abort, this is not a kill. This is a flag. This is your program raising its hand and saying, if you care, somebody would like to cancel this operation. And it's up to you to check that flag and decide what to do with it. So I can create a new token that's in the yes cancellation requested state, hard code that. And before changing any of the code, let's just run this and see what happens. And I should have clicked that button while I was talking because now I have to tell a joke. Okay, so a dog walks into a saloon in the Old West and he has his hand all bandaged up. And he goes up to the bar and he says, I'm looking for the man who shot my paw. Fortunately for you, the application has started. Okay, so I click on the fetch with task button, wait the 3 seconds, and then the button re-enables, nothing happens. This should come as no surprise because we have an empty block in here right now. Now, what I can do instead of having an empty block, I can just say, give this a big canceled like that. And then, great, now I have to rebuild and rerun it again. But you get the idea. So our code behaved exactly as we would expect it to. We hit this is canceled block in our code, which happened to be empty. And so now we'll try it again. We'll click our button, wait the 3 seconds. And now we have our pop-up that says canceled. I click OK, the button re-enables. Okay, so that's a great path. Let's try the same thing with the fetch with await button. Okay, so again, I'll just hard code a new cancellation token here. Pass in a true. And we will see what happens. Maybe. Okay, here it comes. Okay, click the button, wait the 3 seconds, and what we see is we get our regular exception pop up. That's interesting. And we get an operation canceled exception. This is why that throw of cancellation requested is important. Because if we look at our block of code that we have here in our await button, how would we check cancellation? I can't check to see if the task is in is canceled state because I don't see the task anywhere. It's hidden from me. So again, what the language designer said is, hey, you know what? We're going to throw an exception here. It will be a specific exception, which is an operation canceled exception, which can be caught separately and dealt with separately. Let's just paste that in. Instead of error, we will say canceled, but we'll still show the exception that comes up. So what we see here is the reason for that exception. And let's just make sure this works. We'll click the button, and now we get the box that has canceled at the top. So we are actually seeing that. So we can treat a cancellation differently than we treat an exception. And one of the reasons why on line 61, I used just the base exception type is so that that would be a catch-all for everything. But generally, when we're catching exceptions, we want to catch things that we know how to deal with. So, but in this case, it acted as a net that caught my operation canceled exception as well. So when we're talking about the exceptions and so forth, this is actually one of the reasons why this async void is something we want to stay away from. Because if we call an asynchronous method that does not return a task, we have no visibility to what goes on after we fire it. It's truly a fire and forget. Because if we're dealing with tasks directly, we can't catch the we can't look at the properties for the is canceled or the is faulted. So we don't even know if it finishes successfully. We can't even check the is completed successfully property. We don't know if it's done. We just know that we don't even know that it ran. It might be in a pending state that it never runs. And so the reason why having doing an async task is important is so that that task gives us visibility to the process of how it's going. If we do async void, it's true fire and forget. So if we don't care whether it runs, whether it finishes, whether it does anything, maybe I'm doing, a bazillion items that I don't really care if they all make it to my data store or not. I just want most of them to get there, hopefully. But if I miss some messages, I really don't care. Then maybe I do want that true fire and forget. But by seeing how we have the operation canceled exception as well as regular exceptions, if this was not if this was async void instead of async task, then we would have no visibility at all to that. Hopefully that just made sense. Okay, now there is one last thing we need to do, and that is hook up the button because these hard-coded cancellation tokens are not very useful. Now, the first time I did this, I did the thing that I thought would be most obvious, which I said, okay, I'm going to create a class level cancellation token, call it cancel token, and let's just new it up. So we'll create a new cancellation token, and then I can pass it into the getAsync methods. And then down in my cancel button click, I can take that cancel token and set and call cancel on it. Call stop. Call alt. Please stop. So it turns out if you create a cancellation token yourself, you can choose at creation time whether it's in a cancellation requested state or not, but you cannot change it later. Cancellation tokens are read-only if you create them directly. That doesn't seem very useful, does it? Now, in looking through, you might say, oh, well, the cancellation token has this is cancellation requested property. Let's use that. Well, this is a read-only property. You can't set it yourself. Okay, so all I know how to do is create unuseful cancellation tokens that I can't change later. And it turns out, I won't tell you how long it took me to figure out, but read the documentation. We don't actually want a cancellation token here. We want a cancellation token source. And a cancellation token source is responsible for managing a cancellation token. So if I have a cancellation token source, and let's just look at what that has, we see it does have a token property. So it has a cancellation token that we can pass to our methods. Even better, it has a cancel method. So we can actually set that to a canceled state. There is also a cancel after that lets us put in a number of milliseconds or a time span. And I've heard some people use this for timeouts. I just put random values in there when I'm upset with my users. So we will just use cancel today. And we'll start with our await button. So instead of hard coding this cancellation token, we'll use our token sources token property. And I need to do one more thing here. And that is at the top of this method, I need to create a new instance of the cancellation token source. Now, the reason I'm doing this is that there is no way to reset a token. So cancellation is a one-way operation that you cannot go back on. So once I have a cancellation token, I can set it to the cancellation requested state. I cannot go back. And that makes a lot of sense because let's think about this. If I had a cancellation token and I passed it to 5 or 6 different methods, and I said, okay, cancel. And then some of them start checking and say, oh, I need to cancel. And then you say, oh, wait, don't cancel. And then the other ones that haven't even checked it yet keep going. You're going to end up with a mess. So cancellation is a one-way operation. So I start out with a not cancellation requested state, and I can set it to cancellation requested, but I can't go back. So if I want a fresh token, what that means is I need a fresh cancellation token source. So that's why I'm doing this up at the top of the button click event handler that I have here. This application is a little contrived in how it's working. So having the multiple buttons that are doing the same thing can cause weirdness if you click them at the same time. So I won't go into that, but this is just kind of the basics of how this works. So theoretically, if I click the fetch data with a wait button and wait 3 seconds, I will get data back. Yes. If I click the fetch data with a wait button, then click the cancel button and wait the rest of those 3 seconds, I get my operation canceled exception. And that's exactly what I'm expecting here. Now, I am waiting those 3 seconds because I'm not checking that token until after the 3-second task.delay. We'll look at that in just a moment, but before that, let's just do the same thing for our task button. So instead of this hard-coded cancellation token, we will use the token sources token. And then at the top of this method, we will instantiate a new token source. And then we'll see that this runs the same way with this button. Oh, my PC definitely needs a nap after this. Come on, I know you can do it. Okay. So again, we'll just let the happy path go. I'll just click the button and wait the 3 seconds and we'll get the data back. Okay, then we'll click the button and then click the cancel button. And then once those 3 seconds expires, we'll see I get my canceled pop-up. Now, generally I get the question, is there a way that we don't have to wait those 3 seconds? And the answer is absolutely yes, because if we look at task.delay, it has some overloads, which include a cancellation token. So I can pass this same token to the task.delay method. And in fact, here, when I'm using the HTTP client, the getAsync method also has one that takes a cancellation token. So I can pass in a cancel token to that. So most of the methods that are kind of part of the base class libraries and the core things that we use in .NET have overloads that take an optional cancellation token. And so the difference is now, because of that task.delay, once we hit the button, it will cancel immediately. Okay, this is the last time I have to run this program. So, okay. So again, we'll just kind of let the happy path go. I just want to make sure I don't break anything. And then as soon as I hit the cancel button, I get the pop-up. And the same thing here with the fetch data with the wait. As soon as I hit the button, I get the pop-up. And then just out of curiosity, the exception is a little bit different. So when I was checking the token directly, I got an operation canceled exception back. In this case, I got a more specific exception, which is a task canceled exception. And this descends from operation canceled exception, so that's why it gets caught in this block. And notice it says a task was canceled. So this is referring to the task.delay actually got canceled. And so this is what's bubbling up to me. From a programming standpoint, it doesn't really mean anything. I just pointed out because it's a little bit of a curiosity. But operationally, it still works the same way, even though we're getting a little bit of a different message back. Okay, so let's just do a quick review. And the slides are available on the GitHub repo. Let me just grab this and see here. I just want to review some of the properties. So I talked about the is properties, is canceled, is completed, is faulted. This is what you see with .NET Framework. Is completed means no longer running. It does not mean completed successfully. There is an is completed successfully on .NET Core, and that's all versions of .NET Core back to version 1.0 and with .NET Standard 2.1. Now, .NET Standard 2.1 is not compatible with .NET Framework. So .NET Framework does not support .NET Standard 2.1 at all. So so it's not in .NET Framework and it is not in .NET Standard 2.0. So that's something to keep in mind. But there is a status property. This is available in all versions of the framework, and you can actually check the canceled, faulted, or ran to completion. So if you are in an environment where you're using .NET Core and .NET Standard 2.1 libraries, I would say use the is completed successfully because it makes so much sense. But otherwise, the task status is going to be your lifesaver. And then when we're talking about exceptions, when you're dealing with it manually with task, you get an aggregate exception back, which is a tree structure. And there is that magical flatten method to bring it down to a single level. Now, you might have noticed with a wait, we didn't have to deal with an aggregate exception at all. And again, that's because the language designers and compiler builders said, you know what, we're going to unwrap this. So in our case, our aggregate exception has a single inner exception in that tree. So rather than having the aggregate when we use a wait, it just unwraps it and says, hey, here you go. You've got your not implemented exception that you were expecting. And actually, let me, okay, I'm going to have to, I hit a slide because I wasn't planning on getting to cancellation. So let me show this slide. Oh, great, it did that again. Flip screens. Okay. So okay, there it goes. So when we're talking about cancellation, a cancellation token is read-only. So if you create a new cancellation token, you can decide whether it's in a cancellation requested state or not. You can't change it later. It's not very useful. So you will want to use a cancellation token source instead, which does have a token property, and it does have that amazing cancel property on it. So that is the whirlwind tour of task and await. If you're looking at task, we've probably covered maybe 2% of what task can do. So there is a lot more to explore, especially if you're getting into parallel programming. Await, we've pretty much covered what await is. So await is basically saying, you know what? This is this thing that people need to do 95% of the time. So let's have an easier way of doing it. I need to kick off an asynchronous method. I need to wait for it to finish and get a result back, and then check for exceptions and or cancellation. So taking that basic, here's a core thing that is going to be part of your normal daily life, and give it an easier syntax. But if you need to step outside of that world, then the entire task parallel library is available for you. So I will pass it back unless there are any questions that are coming in at the end.
Anyone have any questions?
Yeah, don't make me tell another joke.
No, please.
Oh wait, I will anyway. Okay.
Ah!
What did the pirate say on his 80th birthday? Hi, matey. Hi, matey. Yeah.
Wow.
Yeah,
That
they
was
keep coming.
it's great. So do people invite you back to presentations?
Depends on how many jokes I tell.
We've hit the limit.
Yeah, yeah, it's terrible.
I love it. Jeremy, thank you very much for, I know it was very short notice, and we really appreciate you coming out to our group and presenting. I really enjoyed it because I think it was really great to see how your thought process and learning process of going through task and like going from here's what you think is going to happen and here's why that's completely wrong and here's what you should do instead. Like I find that method of going through knowledge is extremely helpful for me personally and maybe other people as well. But you've got your website. There's some links in the chat, and also you can go to jeremybytes.com for a lot of information, and there's
Yeah,
all the
and
content.
at any time, if you go to jeremybytes.com, at the top there's a link for demos, and click on that. And actually, let me just show you what that looks like. As long as I have Chrome still open, eating up all my resources.
All that RAM.
Yeah, let's go back here. And okay, so here's my website, jeremybytes.com. If you go to the presentations link that I have at the top, this has all the presentations that I've done. So you can see Houston.NET user group is here, and it will remain on this list and slowly scroll down as I go to more events. And then that will take you to the links that I showed earlier. And again, highly recommend these async experts because they will get you past the basics that I just showed.
Nice. Well, thank you very much. So I want to thank the GHADNUG board as well as the North Houston.NET Users Group board for coming together and having everyone together. And it's good to hear everyone and see everyone. Well, hear everyone in the kind of remote times. So if anyone knows of any job postings, please make sure you post it up on the LinkedIn or the Meetup. And if you're looking, go ahead and post as well so we can kind of make connections as we see people that are looking for things. We are planning to do another Greater Houston.NET Users Group meeting next month. Mukesh Dhanawat with Metadata is going to talk a bit about their architecture, and I'm going to follow up with him to make sure that he's available still. But we'll have the same venue. We'll use WebEx. We'll make it happen, and we'll post some information about it pretty soon. Thank you guys for coming out, everybody, guys and gals and everyone, and have a good night. Stay safe out there.
You guys, I appreciate it. Thanks for hosting. Jeremy, thanks for the talk.